Recording is on.
Hello, everyone. Welcome to this little bag of MISC, kind of random collection of, it's mostly like shell tricks and tools and something that I've collected over the years. And of course, a bit of a workflow here that I'm using for code hacking. I'm very much looking forward for input into further ideas and learning what everybody else is using. And a bit of Git, etc. So as I said, quite a bag of MISC things. This is today. Let's start with shell and more things, because that's where I guess many people spend quite some time in. So getting shell, knowing your shell and being productive there and knowing the tools probably, hopefully, is a bit of a productivity boost. There's this wonderful The Art of Command line, which I recommend if you have a few bit of time to spare. Just read through that. Many of the things in the next few slides are mostly taken from there and amended with my own and other people's stuff, of course. So readline is the kind of input handling that gets used in many shells. So knowing the shortcuts there is quite useful. If you are frequently logging into remote machines, this Bioboo is super useful. It's a way to have persistent sessions with some sort of session management. You can also use that for screen sharing if you, let's say, need to debug something on a server and then want somebody else to look into that, because more than one person can kind of share that buffer. There's a number of essential keyboard commands that I think for many people the most productive one is this interactive search backward, this Control R, and then just type there. The slides will be online, so I'm not going to go over all the details. If you find something that's missing here, or if you have questions on anything, just type that in the chat or speak up. We got the time to cover that, and I said most of that is just a copy paste and a resource collection. We won't have the time to go in detail over all the slides. Quite useful if you want to demo something is recording terminal sessions. There's ASCII Nima. I like that tool. It's nice when you want to have something nice on your Git inside your Git repository, for example. Compresses very into something very small. You can even edit that recording if you have somehow mistyped. Then the usual basic tools that everyone should be knowing and using, like Xargs, if you want to run something on a number of files and you don't want to be tripped up by shell quoting and spaces, etc. GNU Parallel is quite useful if you want to parallelize on something, let's say convert a chunk of files, grab through something. We also use that, for example, for the Windows packaging to parallelize that, etc. And then the usual, let's say, find what's going on your machine, which sockets are used, who's listening there, that sort of thing. Quite useful. I think it's not super widely known, is something called process substitution. Just to have it mentioned, which treats program output as a file. So that's at the very bottom of the slide. So you see this is actually generating standard output and then piping that into the diff utility. So you can diff, in this case, two host configs from two different machines. Saves you some temporary files sometimes. Then the usual tricks here for shell scripts, like the SEER document, so you can have something already verbatim in the shell script. JQ, super nice for JSON. It's kind of a query language and let's say grep on steroids. So just to show that thing. So what's it doing is going through that file. This is an actual metrics JSON export from an older conversation. And then you have some query syntax there and a selector like a database query, something that I set, and then you print. The action is then to output the body of that little sub element there that matches that query, so that something like that comes out. So quite useful for larger data processing. Or if you want to normalize and pretty print that, then there's this sort key thing. Data mesh, just wanted to list it here. Super nice for also for data mangling on the shell. So most of what data mesh can do, you can also do in calc, of course. But of course, calc is a bit less scriptable. So if you want to process large amounts of data, kind of transpose and reverse that, then data mesh is your friend. Org and set, you probably know that. No point in going deeper there. Sort and unique, super useful. Unique, so this is essentially shell, like sorting a text file. And once you have it sorted, you can call unique, which usually just outputs the lines that are like one line each. So if there's duplicates, it removes that. But it can also kind of find what's duplicate or find what's only unique and sort out everything else. And yeah, paste is quite useful to collate 2 or 3 or 4 files into one, same as join. So in this case, so that's the output here, and with paste sequence is just writing that 1 to 6, and paste then. So I take standard input, so it takes one element, one line from every time there. So it takes the 1 as the first entry here, and then the 2 as the second, and then it's the next line, and it continues there. So if I go with 2, then obviously I get this. And join is let's see if I have the shell history for that. So let's go with something we have. Okay, well, you have it sorted. Okay, so join essentially throws 2 files together, 1 line from each, and then you get the joined input there. Let's move on. System info, like knowing what's going on your system, the usual process listing that you all know. One of my like figuring out, because that gives a bit better hierarchy and it's a bit nicer than btop or htop, which is constantly updating. So this forest is kind of useful because it has this nice hierarchy there. So it's much easier then to find what's going on your system. If you want to troubleshoot, like I/O is slow, machine is slow, what's going on there, then the SAR and IO top are quite useful. But also, like if you have memory pressure free and VM stat. If you happen to be in the unfortunate situation to run something with Java, which happens, for example, if you run Jenkins, some diagnostics there, quite useful to get something out of the Java virtual machine with this JStat, JMap, JStack tools. Just having it listed here. And also kind of sending signals to Java server instance to get some stack traces and heap summaries. They're quite useful when you need to inspect a live system. Network, you might know that. I'm just having it listed here. IFTop is nice for checking what's going on your interfaces. What's the load there? ngrep, super useful if you want to have this very quick check on what's going on a socket, combined with some graphing and filtering. So yeah, there's this sample, like getting all the HTTP traffic as long as you run the command or graphing for this hex or binary pattern on port 80. And many more things. Further reading, you can find that here. Particularly useful if you do number crunching, CSV tools, CSV SQL, CAT, for example. This is some query language similar to JQ, but for CSV files. Also conversion between XML and JSON, quite useful if you want to run some analysis on, let's say, ODF and OXML files, because JSON tools tend to be a bit nicer these days. Or some real numerical analysis with R as an analysis language. There's also command lines for that. Or if you like the interactive thing, then Jupyter Notebooks. If people who know Mathematica, that's quite similar. All right, so that was the first quick run through shell tricks. Any questions so far, or additions or something that I misrepresented? If not, let's continue with Git. Work trees. So my work. So this is my workflow. This is of course your workflow might be different, and that's fully valid. But this is how I work. I tend to keep one very pristine clone that I use for pushing, because that's easy then to switch branches, to cherry pick, to interactive rebase, because you will never destroy any checkout, you will never destroy any work tree that you spent an hour to build. So I have one tree that is usually pristine, and there's nothing much in, and there I frequently switch there. For them being able to nicely cherry pick things and move changes and code around, it's super nice to share the actual Git objects. And the recommended way, at least from my side, is to use work trees for that. So with that, you create a different directory, let's say different checkout, but it shares behind your back, it shares the Git object. So you can do things like cherry picking in different directories, because you all have the same, let's say, local Git database with all the objects. So how that works is git work tree add, and then give a path there and a branch you want to check out. There's work tree list for if you forgot where you put them. So let's say that's my stuff here. And of course you can remove it as well, but usually it also works by just RMD that. Git is pretty smart figuring that out. The one catch is that the branch needs to be unique, so you can't have the same branch checked out in multiple work trees for internal reasons, but usually you can, of course, if you want to work on the same branch in different trees, not sure whether that makes sense, but if you want to just create a small local branch that you name differently, and there you go. Yeah, it makes sense to have rebase enabled. That's a global configuration for our work. Daily routine, commit early, commit often. There's some links there for the setup for online contributors. Make sure that you commit with the sign-off, otherwise the developer certificate of origin foo will not work. If you want to fix up something, use amend, of course. One of the superpowers is this interactive rebase. I will get to that in a second. Just one more thing: if you collaborate on something on a patch with someone, sometimes it's fair to give that person then this co-authored line. So I mean, if it's just a review, but if someone is substantially contributing to your patch, it's a nice nod to them to add them as a co-author. And there's a standard syntax for Git. Just put it in the footer with this co-authored by, and then the name of your colleague or your reviewer who did that. Yeah, with in particular on core, it frequently happened that someone moved things around during some cleanup, and a very long history of that. So make sure, if you are sure that there was something where you can't find it in the log, add this -- follow to get history across moves. The other thing, if you want to really know why something is the way it is, and you're into this Git archaeology, there's a very nice and useful OpenOffice history repository that includes not everything, but almost everything from the early days, which was this CVS version control system. It was then Subversion. There was lots of branches and tagging, which then sometimes got squashed into single commits. So it's very hard to figure out who did what and why. And this history zip archive is a Git repo with all the branches. And as I said, it's useful for doing this kind of history and figuring out what the hell was going on, who did that and why. Submodules, I'm sure you know that. If you don't do translation, you probably don't need it. So let's skip over that. Always useful to have a nice shell so that you see, in this case, what's the repo, what's the branch, what's the status I'm on, what's the result of the last command there. So one of the simple things that was z shell for bash, for example. That's the standard prompt, but most distros come with that out of the box these days. Rebase Interactive. As I said, one of the superpowers to use in Git, because that is something when you've been following advice and you've been committing a lot, like every hour, every 5 minutes, then you get a very messy local history. Usually you don't want to push that as is. So you want to clean that up after the fact. And Rebase Interactive does that. So it gives you a way to edit your commits after the fact. So let's try that. Let's go here. So what it does is it rebases itself. So you can kind of rebase onto your current branch, and you can say, I want to kind of edit the last 6 commits here. So you do that, and then you get, in this case, this. Let's make this a bit larger. This is my Emacs buffer, but you can get that in your shell just the same. So if you haven't configured Emacs, you will get the same query in your shell. And what it does is it kind of takes the last 6 commits and already puts that here in the buffer. So if you don't do anything, you don't edit that, they will all get applied as is. But what you can do is you can edit now. So for example, you can say, I want to drop this one. So it gets dropped. So when I kind of finish this buffer, it will simply not be applied. What I can also do, I can reword the commit message. So when I now exit this buffer, it will then apply the first 3 commits and then pop me back into my editor to edit the commit message. More interesting, perhaps, is something like squash. Squash means merge that with the previous commit, but keep the commit message. And probably even more relevant, at least for me, is the standard fix-up. So I changed something 4 commits, 10 commits earlier, and then I realized at the end, when I run the unit test, that something is broken. So I need to fix that commit. So I make a local change, but of course the local change is, let's say, here. So I have this kind of, well, this is not real, but I have this fix up. So I have this fix up here, and I need to somehow move that commit up here. So I can simply move that up and then fix up this commit in this particular case. And fix up means it will vanish, so it will just be merged into the previous commit without leaving any traces. So I can have more embarrassing, or there's some compiler breakage, for example, and I didn't notice because I didn't build the unit test. And later I realized, so I fixed that up and I merged that into one commit. Right. In this case, I'm not going to do anything here, but yeah. So that's the ultimate way that that allows you the fullest flexibility to make sure that your history is clean. So it's essentially a git command, a git commit amend, but run that in a very flexible way. You can also split commits, for example. I'm not going to show that, but there's enough tutorials for that, where I can say I have a commit, but I actually want to have that in 2 or 3, so separate hunks out there and have the separate commits. Right. This is a bit more details how to do that. Also how to separate commits into. So the way to do that then, if I go back here, is to say I want to edit this commit. So when I say edit, then and I process this, then. So let's execute that. So in this case, I get popped into the shell with the the change applied, but I can then git reset, like described here, and add individual parts of the change with the git add interactive. All right, and as always with git, I can always abort, and then I'm back where I was without any damages. So that makes it life much easier. One last thing on this, because I learned about this quite recently, but it's kind of even nicer for this common workflow that you need to fix up a lot. So let's assume you have this, that happened exactly what I just described, was that you did quite some feature work and you have like 6 relatively large commits. And you realize after building and testing that there's quite some changes still necessary. So, but it's already all committed. So what you can do is then actually make your changes in your work tree. And now you need to manually kind of separate this out because you have 6 commits and your changes might in turn apply to commit number 1 or commit number 2 or commit number 5. But well, you don't know that. You first need to check like which files did I touch. And it's quite a nuisance. And git absorb has this wonderful functionality of figuring that out for you by just looking at which files you were touching. And it goes back in history and finds the last commit that touches this file and this hunk and the lines that you've been changing, that are changed in your local work tree, and then creates a fix-up commit for that. There's another nice feature with git rebase with this auto squash, which takes lines that are prefixed with fix-up and automatically merges them with the relevant line without the fix-up, with the relevant commit. And both of that taken together, you can say git add, git absorb, which creates those commits, and then you can run git rebase interactive auto squash to finish up, and then you have all your fixes in, and you can push that, and that's kind of super nifty. So more tiny little bits and pieces. Resetting a tree. Just bear in mind that there's several ways to reset. By either just changing the commit you're on, or the git things is on top, or by changing the index, or by changing both the index and the work tree. Yeah, of course, you can always check out a specific file in a specific version. You can show a specific file in a specific version. You can search in very many ways. There's some, if you want to kind of do some mass changes, there's some just some selective shell tricks here, how to do that. Very nice is a bisecting. If you have something like a unit test that can tell your shell success or failure, you can run this automatically without having to do anything. This snippet here does that. In this case, on a relatively large host with 60 cores. Merging, sometimes that's necessary. Bear in mind that you can, if you merge and there's no divergence, you get this fast forward thing. So merging is also a very nice way to get your branch on top of master. It's not always creating a merge commit, which is probably not so nice to have. So you can also use that to just get your feature branch if you have rebased it before to get it in. Some releasing, how to do that. Let's skip over that. Useful git config. Let's move to my little config and go through that. So probably the thing that is not very common is the delta, which is the way that git diff works. So let's make some changes. Of course, if there's no changes, there's no fun. So there is this kind of side-by-side diff now. That is the config here is a side-by-side true. Then wrap lines is like, if usually with side-by-side, sometimes the lines are not long enough. So then the question is how many wraps you get until it gets cut off, etc. So yeah, just look that up, the delta config here. You can have a syntax highlighting theme. For diff, it's kind of useful to configure that because there's some heuristics involved, of course. Make sure to have your identity set here. What else? Oh yes, aliases. That's kind of useful. So it's a bit like a shell alias, but inside the git command, where you can add some for example, this is kind of useful for getting an idea how the branches are looking. So yeah, there's some bits here. Also this DF, like if you want to, it's not always nice to have this side-by-side diff. So maybe you want a different diff, or maybe you want to copy paste something out of your shell. So then it's kind of useful to have different setups here. Right. There was that. Recovering from errors. Yeah, as I said, there's always a way out of your misery with Git. So the worst case, if you've really deleted something, Git reflog, and if you realize that within, let's say, a week or two, Git reflog always has the commits still there that you've just deleted, the branch you've just deleted, the commit you've just reverted. If it's in Git, like if you have committed it, you will be able to retrieve that. Which is another good reason to keep committing a lot. Okay, let's move on. There's more snippets here. Slides will be shared. But let's go over that. Yeah, Adam Spears, one of the former SUSE colleagues, has some really nice tools there. Like if you're really into Git, then you will be delighted to play with that. But I think we're running slowly out of road here, and I wanted to show at least my setup for code hacking. Justin says, execute a bash script helpful after a squash to be able to amend. Oh, yes, indeed. So you can execute things while doing this interactive rebase. So there was, I think, my Emacs was even mentioning that. Yeah, so in this case, I can give a shell command here. But anyway, we want to end this. Right. Then next up is code hacking. So initial setup, you need a core build, of course, at least if you want to hack that. That's my setup here. Perhaps to highlight is enable the Cypress tests so that they actually run, and enable browser sync because that's much nicer than when you want to edit JavaScript and have it updated in your session. Don't forget to build with explicit parallelism, because in comparison to core, the online build is usually single-threaded. Debugging, just linking to the how-tos here. If you run a development build, then you will find some extra view widgets here where you can play with the styling with all the native widgets. Yes, when you want to run it, there's some nice makefile targets. I guess most useful is make run -gdb if you want to have a debugging session right away, which is sometimes if you have lots of tracing going on and you are, like I am, like running your GDB in TUI mode in your terminal, it's kind of disruptive. So you might be better off to make run one in one shell and then attach your GDB in another shell. So that way you get the tracing on one side and the GDB terminal window in another. There's a few more references here to slides from wonderful colleagues on that. how to do this kind of diagnosis thing. If you're doing things in, let's say, on the core side, then the GTK tiled viewer is a really nice way to debug that without having this in-browser and multi-process and event passing thing there, because that's using the same tiled rendering engine as online does. Browser sync, as I said, super nice if you're hacking JavaScript, because that avoids this constant restarting cycle. So you just change something and then you do make, for example, sync writer if you're running writer, and then if you've configured and built that with enable browser sync, you get it updated in the live session. So that's mostly it. I think I'm quite a bit over time. Sorry for that. Thanks a lot. Yes, just to have it mentioned, we're hiring, so please reach out if you're interested. And let's open for questions now.
That's brilliant. Thank you so much, Thorsten, for that. Has anybody got any questions? If not, I'll just go through person by person. Okay, let's start from how I can see it on my screen. So Andrash, Benobi, Quaylon, and Darshan. Any questions?
No questions. Thanks, Thorsten, for the presentation.
I have some things that I always forget. When you're doing the git log, for the git follow, I think there's some sort of limit to how many renames it will go back on its own.
Yeah.
There's configuration option.
Yes. Indeed. So that is, let me find the config here. So there's a config for that. Let me find that. I forget myself. Oh yeah, it's a rename limit. So this is some weird misnamed obscure setting that is under the div section. And if you crank that up, it also takes a lot more time. And usually that gets cranked up in the in Git releases over the years because machines get more powerful. But yeah, so and that's worth mentioning. So if you are really sure that the file should be there and it used to be named something else, but git log is kind of fooling you and git log follow is also fooling you, then you might want to bump this up temporarily at least.
And then the other thing that comes to mind is when on GitHub, it's just a GitHub's peculiarity is that if you have created your own branch that was based off, let's say, CO2504, and you push to GitHub and it gives you that little URL to visit to merge your patch. When you visit the website on that, it will automatically have selected to merge to master, not to merge to whatever the original branch that you branched from. So that if you just, on backports, if you push that button, then you get this kind of disaster looking thing where you're trying to merge 90,000 commits to master when actually you wanted to select the actual CO24 branch and merge in one commit. So just when you're doing the backports, and if you follow the link that it gives you, select from the drop down the actual target branch that you want to merge to. I've seen various people do this, including myself, just automatically clicking OK, and the defaults are rubbish.
Yeah, apparently I wasn't burned with that by that, but I will absolutely add that to the slides. Yeah, those kind of paper cuts, super useful to have it mentioned.
Yeah, that's it for me.
Brilliant. So the next people I have on my screen are Jo, Helki, Gorkai, and Aaron. Questions? Brilliant. So then I have Justin, Kurt, Michael, and Tima. Any questions at all?
Yeah, maybe something side issue, like thank you for this. Previously, you had a nice presentation on Z Shell. And now from this, did I understand well, you don't really use it daily or how?
Sorry, I wasn't quite sure what the question is, whether I'm using Bash or
Z Shell.
yes. Yes, I do use that. It seems to be kind of making rounds.
Brilliant. So the next people I have on my screen are Miklosh, Vikesh, Parth, and Rashish.
I would have two small remarks. One thing is you mentioned browser sync, and that's indeed nice. There is some middle ground between a full restart of make run again and again after each JavaScript change and browser sync. You can also just disable the memory caching of JavaScript so that you can run make run with an environment variable. And if you set that, then even without browser sync, you don't have to restart the WSD, but you can just reload in your browser and you get the fresh JavaScript. So you still need to build TypeScript, but you don't need to restart the server. So that might be useful in case you want to simplify your setup and just not use browser sync. The other small thing is in case you backport to these release branches and you would hit that GitHub pull request bad default branch thing, then one way to work around that is that there is both core and online has a script called G at the top, and the online one, G script, has a review subcommand to do the right thing for you. In case you have a number of comments locally and your branch is set up so that the upstream branch for your local branch is the matching, then this will just do the right thing for you without any clicking, and it will get the default remote correctly. So that might be useful. It's a little bit similar to Git review for the Garrett case. In case you got used to just submit your changes with Git review on the core side and you don't want to do much clicking, then the G review on the online side is something similar. That's it.
Yeah, I saw this. I haven't used this this from file system. And the thinking was that it's of course it's a shortcut. So probably if you want to be as close as possible to let's say to a deployment, then this this browser thing will probably still be useful, right?
Sure, it's cutting out different pieces. So it's not good or bad, just one more different thing to be aware of.
Okay, but let me add that anyway. So the more the merrier. I think so. As I said initially, I guess the most use here is actually having the slides as a source for studying and copy pasting things out down the road.
Okay, the last two that I have on my screen is Balash and Attila. Any questions, comments?
No questions, thank you.
Thanks, Attila. So that looks like does anybody have any questions or comments to make before we finish? Brilliant. So Thorsten, thank you so much, and thank you everyone for coming and watching Thorsten, and we'll see you next week.
Thanks a date.
Thank
Bye,
you.
everyone.
Bye.
Bye bye.
Bye.